AP Cram Calculus AB Free Response Exam Review. Question 24. Chain Rule 0.931 raised to the t power. So grass clippings are placed in a bin where they decompose. For a time interval of t is between 0 and 30, and note 30 and 0 are in an amount of days. The amount of grass clippings remaining in the bin is modeled by A of t is equivalent to 6.687 times 0.931 raised to the t power, where A of t is measured in pounds and t is measured in days. Find the value of A prime of 15, where the 15 is, 15 days, and using correct units, interpret the meaning of the value in the context of the problem. All right, so basically we have to take the derivative of this function and evaluate it at 15 days. Some of you know how to, work this out really fast and by putting it into your calculator or by hand. What I recommend on the actual test is just put it into your calculator, find out the derivative, and then, evaluate it at 15. But if you're not so savvy with your calculator like myself, you'll probably want to know how to do it by hand or just the theory behind solving a derivative that's raised to the power of a variable. So here we go. All right, so saying a prime of t is the same thing, or a prime of 15, is the same thing as the derivative with respect to t of 6.687 times 0.931t. So we're just taking the derivative of this, okay? So what we need to realize is that in order to solve this derivative, we're going to factor out this constant. We're going to have to rewrite it. And we know that e raised to the natural log of 0.931 is just 0.931, because the natural log of 0.931 is saying, like, which power do you have to raise e to in order to get 0.931. So when we plug it into e and when we raise e to this, it kind of just undoes the natural log of 0.931. So essentially, algebraically, we didn't do anything. Okay, but just bear with me. Therefore, 0.931 raised to the t is equivalent to e raised to the natural log of 0.931, all this raised to the t power, okay? Because we know this is 0.931, but we still have to raise everything to the t power because that's the expression we have here. So if we plug this into the derivative, we're going to get 6.687 because we factored out our constant dt of e to the natural log of 0.931 raised to the t power, okay? Now we need to go back in our memories and find this rule, or if it was never there, now it is. So whenever you have a base a raised to the b power, and you're raising that again to the c power, you can just rewrite it as a raised to the b times c power. This is a rule of exponents, okay? So we're going to incorporate this rule. Therefore, this derivative becomes 6.687 dt of e to the ln of 0.931 raised to the t, but that becomes dt 6.687 times the derivative with respect to t of e raised to the natural log of 0.931 times t, okay? So this is the change we made from here to there, all right? And now we're going to have to use a chain rule to evaluate. So we know that the derivative of e raised to anything is just going to be that thing. So we rewrote our constant. This isn't being evaluated in the derivative. We're multiplying that times e raised to the natural log of 0.931t, because the derivative of e to anything is just going to be the exact same thing that's being evaluated within the derivative. So that's our outer function in the chain rule. So now, according to the chain rule, we're going to have to multiply the derivative of the outer function times the derivative of the inner function. And the derivative with respect to t of the ln of 0.931t is just going to be the natural log of 0.931, because, you know, like the derivative of a variable raised to the first power is going to be that variable raised to the 0 power times the constant that precedes it. So this becomes the natural log of 0.931, okay? So this is basically our general derivative, but now we have to evaluate it at 15, and in order to do that, you just plug in 15 here and, you know, solve this in your calculator, and you get a negative answer. And this makes sense because the grass, you know, is decomposing, so there should be less and less and less. Like, amounts are being taken away, not added, so that makes sense. So in the context of this problem, the amount of grass clippings are decreasing at a rate of 0.164 pounds per day on day 15. This is the rate of decrease on day 15. Okay? All right.